Welcome to the first GSE Sesame Colloquium Talk of 2019.
All right.
I'm delighted to have Lisa Hardy here to kick the semester off for us. Lisa is local in a couple of senses. First, she works at the Concord Consortium, which is a nonprofit that's based in Emeryville as well as in Concord, Massachusetts. Second, she recently finished her doctorate in education at UC Davis. That was following a double major in physics and biochemistry, also at Davis, and a non-local detour for a master's degree in physics at the University of Wisconsin. Her research focus is also close to that of many people here. She works on the use of technology in STEM education to promote engagement with science, reasoning about models, and deepening ways that students interact with data. Today she'll talk with us about from data collectors to data producers, shifting students' relationship to data. Please join me in welcoming Lisa Hardy.
I'm Lisa. I work at the Concord Consortium. So this is a nonprofit educational technology and research company just about 15 minutes away in Emeryville, where one of our offices is. What I want to talk about today is shifting students' relationship to data. And we remove them from being data collectors, and I'll explain this a lot later, but move them from being data collectors to data producers. So I'm going to talk a little bit about some thinking about what that means, and also about how students encounter and work with data in their science classes, but with a particular eye toward the sorts of understandings of the nature and uses of data that they might develop. So we think these are particularly important things to think about right now because we now live in a world where data are everywhere. We have sensors on our wrists and our pockets. We interact with computers and servers that record our interactions with them and with each other. And so data is now becoming more of a part of our daily lives. It's not just something that scientists produce in labs, but it's something that's becoming important in public discourse, for example, around privacy and uses of data or violations of privacy. So I work on a project called the Inspect Project, which is a STEM plus C at Concord, with the PI is Dr. Sherry Shee, who's a graduate here. And what we're trying to do is integrate computational thinking into the sciences with this particular approach where we're doing this through programming for data acquisition and control. So we are doing a few things. So we're developing hardware kits with sensors, actuators, and programmable computers in them. The sensors are like biological sensors like carbon dioxide, oxygen, temperature, humidity, soil moisture. And what we're doing a bit differently is instead of sensor kits, just with these sensors, we're also including actuators and these programmable components. And so what students are doing are things like writing programs to turn on and off lamps or relays to stabilize temperature, for example, and in service of experimentation. We're also developing Dataflow, which is an online programming environment where students write these sorts of programs and then send them down over the internet to computers in the classroom, to these Raspberry Pis, which interface with the sensors and actuators. And we're developing to work with these kits and this software, we're developing sets of laboratory activities that students do in their science class. And we're focused in particular on 9th grade biology. And due to the nature of the sensors, that puts us kind of in some particular content areas, so photosynthesis and respiration and ecosystems. So, what those labs normally look like, and this might look familiar to a lot of people, this is just a section snipped out of an older version of a lab that we had. Students make some predictions about what they think is going to happen in their lab. They go through these procedures where they collect data, and then they analyze it and explain it. Maybe present their findings to their classmates. And so this particular one is also relevant to some things students are doing later, so I'm going to kind of take a minute to sort of explain what students are doing in this sort of lab. This is a lab where they're investigating matter and energy flow in plants, and particularly learning about photosynthesis and cellular respiration. What the lab part actually looks like is they do this with spinach leaves, which are still photosynthesizing and still respiring. So they take these leaves and they lay them out kind of carefully, flat in the bottom of a container. They stick some sensors, like a light sensor on the bottom, a carbon dioxide sensor on the side. They seal everything up very carefully with saran wrap to make sure that there's no leaks in this little environment. And if you follow these procedures, you will get some nice looking data. And so this is what this looks like if you sort of do the data collection in this way. In the dark, the data go up, and in the light, they start to go down. These are very useful sorts of data sets in a biology class because you can attribute these CO2 rises in the dark to plants doing cellular respiration. And in the light, photosynthesis, when you turn a bright light on, photosynthesis will kick in and start to drive down the CO2 levels. And so we use these to develop student models of respiration and photosynthesis in plants. These sorts of labs are very useful to bring scientific phenomena into the classroom, to engage students in NGSS practices of collecting and analyzing data, developing models. But my fear about this sort of lab is that what we're doing is giving students the wrong ideas about the nature of data. So I'm going to share a quote from a student after she did one of these labs, very similar to the spinach lab. I'll take a second to read it. So I see kind of two things wrong, two problems with this quote, reasons why we should feel sort of badly, I think. One is that we put this student in this position in her science class where her job was to follow recipes. And that's not what we want science to look like. Related to that is that her data was supposed to be a certain way. It was supposed to do something and to have this particular behavior. And it was supposed to do that for everybody in the class. And students are very aware of that data is supposed to do a certain thing. So these sorts of labs kind of suggest that there's this idealized data, and if you don't get it, then it's because you messed something up. And so what we want to think about is that really the sorts of experiences students should have in science class, and what are they getting out of them about data. So the question is, well, what do we want them to get out about data? And I'd like to make an argument here that we don't want people to see data as collected, as we talk about it in science class. We do want them to see it as produced. And the argument that I'll make is that we should think of it as produced in a few ways. That it is an artifact of a very human, technical, social, and material process. And the sort of model that you can kind of keep in mind as I talk about this is one of people intentionally sort of pressing these technologies and devices and instruments into the world to produce data that's going to further their own purposes. And this is in contrast to this idea about data collection, which sort of suggests that data is this natural object that just kind of exists in the world, and the scientists go out and collect it, and it would be the same if I did it, or the same if you did it. And the relationship between data and the natural world is actually quite a lot more fraught than that would suggest. So I'm going to talk about Pickering's description of science and of where data comes from in this particular lens, because we think this is useful for thinking about it. So in this case, humans, technologies, and the material world all are necessary to producing data, and they all play a very active role that he characterizes as agentive. So in this view, the story of science goes kind of like this. Scientists have goals. They want to do particular things. He uses this example that I'll just kind of continue through of a particle physicist, Glaser, who wanted to capture cosmic rays. And this is what his goal was and what he wanted to do. And he wanted to do it in his laboratory. And so in pursuit of those goals, you have to develop and carefully orchestrate an array of technological devices, and these things are developed over time to produce particular sorts of data. What happens is that these devices will fail to work, or your ideas about particle physics are wrong, and you won't be able to achieve this goal. And so he called this was a pushback from the material world, that it was resisting his efforts to capture parts of it as data. And so these pushbacks he called material resistance, and it was an exertion of the agency of the material world. So there are scientists with intentions to do particular things and with pushback from the material world. So what the scientist does in response to these pushbacks is what he called mangling. They revise their conceptual models, they revise their accounts of how data got made, they redesign their instruments, and they adjust practice. And so in this description, technical knowledge is intertwined with scientific knowledge, and they both emerge in this activity and co-evolve. One thing that I want to point out, because it's important to our thinking about students producing data, and the way that they do it is that scientists' goals are not purely conceptual. In this description, it's not like scientists have the goal of answering a particular conceptual question or developing a particular model. Their goals are broader than this and situated within a discipline and an institution and a broader society. And for example, in this case of Glaser, he didn't want to just capture these cosmic rays. He wanted to do it in a way that aligned with his own preferences for ways of doing science. And so what he wanted to do was not do big science, where he would go to a national lab to do this sort of work and work with armies of people and manage them, and he didn't want to work in that way. So he wanted to do small laboratory scale science. And so this means that the way that he approached science was, it was actually much harder to reproduce these, or to capture these cosmic rays in the laboratory, but this is the way that he wanted to do it. And so Pickering called this the work of cultural extension in science, that he had a desired future culture that he was aiming for, and that's why he was engaged in this data production activity at all. So I want to talk about some of the implications for the nature of data if you think about data as produced rather than collected. So going back to this idea that there are people who are intentionally pressing their instruments into the world to produce data that furthers their purposes. So data is really produced at that intersection of the natural and technological, which means that data is always part fact and part artifact. So scientific activity is largely about teasing apart those features of data that are real, that are attributable to an underlying phenomenon, and those that are artifacts of how it got made. And so as an example of where this became relevant, there was a recent, I think a few years ago, a hiatus in global warming where it appeared that the temperature, global Earth temperatures had sort of leveled off and stabilized. And so this was used as an argument that global warming is not a concern because the temperature is not rising. And it ended up being due to the ways that the temperature was measured, the sensor placement relative to some particular ship intake systems that artificially affected those temperatures. And so that data being not just a direct reflection of some underlying phenomenon like temperature changes, but partly due to the way it was produced, and that became important. So that data is produced with these designed technologies that embody human knowledge and values. What happens is that, so scientists are making efforts to better capture data. Better capture phenomena as data. They redesign these devices and they create better and new ways of doing this. But what that means is that these tools come to embody both their beliefs about what phenomena exist and what phenomena are worthy of measuring, and how you do that and capture those phenomena as data. How do you reduce complex behaviors to forms of data? And so what that means is that data is laden with theory and knowledge and values. What data can even exist at all? And so an example of this is even what we would think of as sort of low-tech survey instruments, like for measuring gender or ethnicity on a survey, are still embody our beliefs about the nature of those phenomena. Okay, last, that data is produced intentionally, that people are doing it for some reason. That means that data is powerful. It is part of the ways that they are affecting changes that they want to see in the world. And this is something that is an important lens to take, for example, to citizen scientists who are trying to monitor changes in their environment and document impacts of fracking, for example, on their communities and their health. And so data, in this sense, is part of this ongoing sort of struggle between corporations and the interests of citizens. So this isn't, this data production idea that intentionally sticking your instruments into the world and producing data doesn't really look anything like what students are doing, for example, in the spinach lab that I talked about in the very beginning. So in school science, these laboratory investigations in particular are characterized by a strong inbuilt disciplinary agency, the thing that governs all the norms and practices of how do you create acceptable, valuable data. And there are some effects of this. One is that what that does is it sets the goal of producing data or engaging in science class. It sets the goal in a way that's determined by us, by educators, and not by students. So on the one hand, what we want to do is we want to engage students in practices that closely resemble those of practicing scientists. So we want them to arrive at canonical concepts. But on the other hand, what we want to do is engage them in sense making and figuring things out and doing this in ways that build on their own prior knowledge and interests. And so these are kind of competing goals where we fix them, particularly in these laboratory type of activities. The tools of science, both like material tools or concepts and practices, are often treated as the object of the activity, like that's the goal of the activity, rather than resources for students' activity. So a control of variables strategy, for example, is something that students will often enact in science class because we consider that something that they should learn, not because it's something that's valuable for whatever sense making that they're trying to do. It's not in service of their purposes. And a final effect of this that I want to talk about is that students have very few encounters with the material world, with what Pickering talked about as material agency, and few opportunities to see that their data is produced in the material world and not just reflective of some phenomenon, and few opportunities to shift and renegotiate practice. And as an awareness of the sort of material context of these activity develops, students should be able to shift and adjust practice in order to respond to those things. Let's see. One other effect that I wanted to talk about is that Pickering's description of science, for example, is taken up a lot and talked about in the importance of emergence of conceptual knowledge and emergence of practice in ways that are sort of intertwined. But despite that focus on emergence, we haven't paid particularly much attention to how students' purposes for creating data emerge in science class as they take up new tools or as they encounter some pushback from the material world. And similarly to how Pickering's sense of purpose for creating data was not just a purely conceptual one, we should broaden the sense of purpose that students might take on in producing particular sorts of data, that they might engage in it in ways that are aligned with their own interests or identities or desired learning trajectories. So what I'll talk about after this is what sorts of shifts do we need to put in place in classroom activities so that students can see data as produced and be active agents in their production. And so on the left here is kind of these things about data production that we would like students to see and to encounter about and be familiar with about data. And on the right are some things that I think need to happen. We need to engage students with the material world, and this could be in designing and redesigning devices and the setups that produce data, in making sense of them, how they work, how they produce data, creating interpretive accounts of how data came to be that incorporate sort of aspects of this material setting. And in drawing on, we think that by doing this also we can open up sort of space for students who are interested in design or aesthetics or who want to do science in these particular sorts of ways. To position disciplinary tools as resources for student goal-directed activity. So we should think of this activity as something that students are engaging on because they have goals and purposes for doing it. And scientific concepts or tools, material tools, or physical ones like sensors or software that they're interacting with are resources for this activity that students are engaging in. And last, that we should attend to students' orientations and their purposes in creating data and try and understand what those are. And also expect that they should be allowed to shift and emerge in time. Okay, so I'm going to talk now about some work that we did with a teacher in this last spring. I'm going to check. Okay, so we knew this teacher from a teacher workshop. He was the maker teacher at a relatively local, large urban public charter school. And he taught 3 sections of 9th grade science. We had worked with him before and at this teacher workshop to sort of brainstorm some activities that students might do in their science classes. And when we were in contact with him again, he was interested in doing some of the inspect activities with his students, and in particular doing something like the spinach lab, and then also having his students after this do follow-up investigations where they chose their own questions and pursued them by building their own setups. So let's see. Okay, so what this looked like in his classroom, we were there for 2 weeks, where we observed how he worked with the students and how the students worked on with these materials and pursued questions. The way that this went is that he gave 2 days for the students to do something that we were calling Tinker Time or Sensing and Responding Lab. These are introductions to these sorts of computational tools that we were producing on the Inspect project, so sensors and actuators and programmable computers. So it was during this first few days that they were learning how to write programs, learning how to run them on these hardware kits, and sample data and control things. So this was, he gave them 2 days to do these activities. For the next 2 days, they did something very much like the spinach lab. The way that he ran his class was that in the first few minutes, he would give some sort of general verbal instructions to the whole class. They would go off and work on the things that they were going to work on, and he would, throughout the rest of the class, walk around for these 80-minute periods, walk around and work with individuals in small groups. And at the end, there was a sort of summary of mostly a cleanup time. So they had 2 days to do something like the spinach lab, but where he showed them an example, the sort of demonstration setup, and said, okay, you will be making 2 data sets, one with spinach in the dark for 10 minutes and one with spinach in the light for 10 minutes. And then that Friday of the first week, they had a discussion about that data. And so what I want to do now is I'm going to talk about a case, like sort of a slice of this classroom activity, and to try to convey here the sorts of varieties of ways that we saw students engaging in producing data. And I will talk a little bit more about how different groups, how different student groups sort of took on different projects after this spinach lab discussion. So we were there, we collected data, or produced a bunch of data in that classroom. We were there for 2 weeks daily, where we were observing, taking field notes. We interacted with students as they were mostly in a sort of tech support role, that when they needed help with some of these things weren't working, or there was some problem, and also just talk to them about, what were they up to and what were they thinking about, what was going on. We had focal group audio and video, photographs of student work, and both of their experiments and their lab notebooks that they kept as they did these projects. We had given them a background and interest survey about had they had prior experience with technology, do they use computers often, do they work with electronics at home, some questions like this. And then we interviewed 18 of these students after about how these experiences had gone, both with these introductions to the sensors and the spinach lab and these independent projects. So what I want to talk about is a case of this very weird data set that stood out in the classroom and played a large role in the classroom inquiry. So what had happened is that after the spinach lab, the teacher was leading a classroom discussion about what had happened and what they had all seen. And he had drawn on the board a sort of consensus that they called a conceptual model. And it was a consensus sort of about what they had seen. So in the dark, everybody said, okay, it went up. And in the light, they said, okay, so it went down. And this is what you expect when you do the spinach lab. So one kid, Fernando, though, had different data. And it didn't show that at all. His didn't go down in the light. It went up slowly in the light and then up quickly in the light. So this was introduced in the classroom discussion as this sort of other weird data set that became conceptually important. So the student had thought they had screwed up in producing this data because they put their lamp on the side rather than directly on top like everybody else had done. And so there was a lot of discussion this day about like what he had done and why that made his data like this. So prior to that, they had been thinking about why the light would go down, or why the CO2 levels would go down in the light. And they kind of agreed that this was, okay, photosynthesis, we already learned about this a little bit. Like they had some ideas about why CO2 levels should drop when the light was on, but they didn't really know why it should go up when the light was off. And so they talked about it quite a bit, that some students thought that when you turn the light off, the plant doesn't have the light it needs, and so it's kind of like seeping back out the CO2 that it had just taken in. Others thought that when you took the light away, that the plant was dying. So it didn't have the light that it needs to sustain its health, and so it's dying and decomposing. And in decomposing, it's producing CO2, and that's why these go up. But in this particular classroom, with Fernando's data set, students started to question this idea that the plants were dying because he had light on, and still they were rising. So the teacher didn't resolve these conceptual questions. He just said, okay, now let's go pursue questions that you're interested in the next week. And then so they had the following week to create data to answer some sort of question that they were interested in. So I'm going to talk about I'll talk about 3 different sort of spin-off projects. These were the set of students that we had interviewed in this class, but they all did projects that were related conceptually or somehow to Fernando's data. This pair I want to talk about because what we saw them do was engage in sort of very different ways with this data and in producing this data. So this was a pair, Akeem and Mala. They were friends, and they worked together throughout the entire 2 weeks, mostly as a pair. And Akeem was active in this discussion, in this conceptual discussion about what had gone on with the plants. And he hadn't been particularly active before. He told us he wasn't interested in technology, he wasn't particularly interested in computers. And then when it sort of turned to Spinach Lab and the science, he kind of engaged more, and he did engage in this classroom discussion, and particularly that he thought that the plants were dying. He thought that they were dying at night. So kind of intrigued by Fernando's data that suggested something else, he wanted to sort of develop these ideas more about how that plant is actually taking in and releasing CO2. So he thought maybe, is it kind of like breathing where it can only take in a certain amount of CO2? If we put lots of CO2 in it, does it do it faster or would it do it slower? And he had a lot of questions about this, like can the CO2 levels ever get down to 0? And so he had a broad sort of set of questions that he was exploring. And so what they decided to do was to try and figure out that question about if you put extra CO2 in there, does it change the rate that the plant absorbs it? And so that's quite a good question. But what they did was breathe by different amounts into these containers, and they tried to do different things, and this kind of shifted over time as they ran into difficulties. So at the very beginning, they tried to do 1 breath, 2 breath, 3 breaths. As it turns out, these sensors max out. There's a maximum amount of CO2 that they can measure, and so when they tried to do this, they ran into this maximum of the sensor, so they adjusted their practice. So they adjusted the ways that they were doing this to start at 2,000, 4,000, and 6,000 for their intervals for initial amount of carbon dioxide. But this was hard. This is a tricky thing to do. So what they would have to do is they breathed into the container a little bit. They'd see it go too high, they'd air it out and close it and try and get it directly at, say, 2,000, 4,000, or 6,000 before they'd seal it up and start collecting their data. So these students did sort of a lot of adjustments as they interacted with the sensors and these setups and thinking about how they were working. But what I want to highlight also is the way that Mala engaged in this. So she was a very playful kid. So when we were doing the tinkering activities in the first few days and they were building things, she was not just like doing the activity, but she was building a clap-on, clap-off light. And so she would have somebody else clap, and then she would try and cover up her sensors to make her lamp turn on and off. And she was doing this approaching this in a very playful way. And we started to sort of carry that orientation into doing the science, where this sensor maximum that they kept running into became sort of a way to mess around and play around in it, where she was doing the breathing while Akeem was doing the data collection, and she would sort of breathe in and then watch the data as it was sort of climbing up and be like, oh no, it's gonna hit it. And so this maximum of the sensor ended up being this place that she was engaging with in the way that she does science, which was quite playfully. This was conceptually rich. They both had very similar lab notebooks because they had worked together. And this is Akeem's. So what happened is, eventually he realized that his data should fit together, like puzzle pieces is what he called it. That as CO2 starts at 2,000 and it rises up to 4,000, that really should be the beginning of the next graph. And he realized that wasn't happening for him. And this was sort of a resistance to his purpose of making sense of this, that was a problem that he didn't know how to account for. And we see in, I don't know if you can read that, see he starts making in making sense of his data, he starts incorporating some of the things about how these sensors were working, that maybe they had a response time. Maybe they took a while, and that's why his graphs weren't lining up. And so what we see over time with this pair, for Akeem, he experienced some resistances, and these were times to think about how the data was really getting made, and to see his data in different ways as things that should fit together in a puzzle piece. Okay, one of the other pairs that did another related project that followed up on Fernando's data were this pair of girls, Linda and Alejandra. So they had a different explanation for this data. They didn't think that it was just the way that how much light, that he had less light on it due to the way that he had sort of placed his lamp on the side, but they thought that everybody else had been baking their spinach, and that he wasn't baking his spinach because he had placed his lamp farther away, and that this would account for these different CO2 changes that everybody was seeing. What's interesting about them, though, is about the way that they wanted to do this experiment. So the way that they wanted to do things. They wanted to not only sort of investigate their ideas that it was heat that was actually what was really important in with Fernando's data, but they wanted to do it in these extreme ways. Like, they wanted to do really hot data, or really hot spinach, and really freezing cold spinach. And they spent most of their time over in these activities trying to create those conditions where they were getting frozen a bag of spinach and kind of wrapping up the sensor carefully and sticking it in a big thing of ice, or boiling their spinach in a hot bath to try and get it very, very hot. And so both of them talked in their interviews about how they valued doing. Linda had called her own little twist on the project. They wanted to do something different than everybody else everybody else in the classroom. They valued doing this sort of unique and extreme thing in this particular way. And they did engage differently within their group. Linda she took coding classes, she was interested in programming, she was kind of recognized by the other students as this competent programmer. And Alejandra built the setups. Like, she was more engaged in this actual creation of these two extreme conditions. They also, like every group of students, encountered some material resistance that, in their case, what they had done is stirred their water and saw their temperature spike. And they started thinking about, why should that be? Why would that make sense? Shouldn't it be the same temperature everywhere? And so these resistances, this was a place that they became very curious and kind of excited to see this happen, but also a place to make sense of how is this thing really working? How does my temperature just spike when I stir it? And so these places again or these resistances to purpose again were ways to really think about how that data got made. The last student who I want to talk about did something entirely different. So she was very skeptical in this class discussion about Fernando's data that the plants were dying. She said, why would they do that? Why would they just die when you turn the light off? And what she did, though, is that since Fernando's data had gone up with some light on and everybody else's had gone down with the light on, she thought that there should be something in the middle, that you should be able to get flat data. And so her project was just to create flat data. She wanted to find that point, that amount of light that would make the data flat. And so in this project, what she did was, and she placed her lamp above the spinach, and then she would layer wax paper on top, and so that she was successively making it dimmer and dimmer, and then she would take data both with the light on and with the light off. And so here, her data she wasn't answering a conceptual question. And she wasn't trying to develop a particular conceptual model. She was just trying to create a particular form of data. But it was very conceptually rich. She was one of the few students who did arrive at the normative conceptual understanding, that there are these two underlying processes that can go at different rates. And this flat data was when they were balanced. Okay. So overall, across these three student groups who had sort of responded to this weird data set, we see many different ways of orienting to this activity and to doing data production. This was both conceptually, like in the case of Akeem and Fernando himself, then technically, so toward the actual programming and the sensors and doing this data collection part. In terms of design, like how do you create these two different conditions, and also orientations to do things playfully or do things uniquely. Across these projects, data played different roles. They were trying to either further develop their own ideas, which was this sort of conceptual orientation, or they wanted to challenge other things, like Linda and Alejandra. They didn't think that the other interpretation was correct. They thought it had to do with heat, and they kind of wanted to get it to show that. And then it was also an objective of its own for Mala and Raylene to produce particular types of data or just interact with it in particular ways. And across these examples, these resistances, like when things went wrong or anything resisted their purpose, they were opportunities to become curious or to consider how these sensors and how these setups really produce data, or to see this data and to see these data in new ways. Okay, I'm going to talk about one more student. So what we want to do is kind of understand this variety of ways that students produce data, but we're also if we're thinking about engaging students in data production and having them intentionally take up some technologies and create data with them for their own purposes, how does that happen? How does somebody come to do that? To take these are 14-year-old kids. They have not used sensors very often or done a lot of programming. How do they actually move from being unfamiliar with these sorts of things to being somebody who uses them to answer their own questions? And so we kind of wanted to take look more closely at how students experience that and how that happens by their accounts. So we talked to a student, Hope, who I'll focus on here because she considered herself bad at technology. She didn't think that. She also wasn't particularly interested in it. She told us on the survey that she thought she knew very little. She's like, I use my phone, but I don't get it. And so she ended up seeing these sorts of data production activities as ways to learn a little bit more about technology. And she became interested in that. She did use these tools to investigate these personally relevant questions. So I didn't say that a second ago, but that is the other reason to kind of pay attention to her case, is that she was bad at technology in her mind, and also used these for particularly personally relevant questions. They weren't just they weren't so much about this like a biological conceptual model, but I'll talk about her purposes here. She also we saw her sort of manipulating her data to emphasize her results. So I want to look a little bit at some pieces of the things that came out in talking to Hope in her interview that are relevant to those things. So during the interview, I'd asked her what surprised her about this, about these activities, if there was anything that was surprising. And I was asking to try and see if there was something. Were you ever surprised by your data? Did something ever go wrong? I was thinking that might elicit that sort of account. But what she told us was just everything. Everything was very surprising. So she felt like with these sensors that they had so much knowledge. She saw these things as things that were built by people, that they spent their time and knowledge just to create these things that would let her see CO2. So I asked her, what was that like to work with these things that were already so complicated? And what she said was that it felt like she knew nothing, like she knew very, very little, and this was sort of motivating to her. Come on, you got to at least know a little, is what she said. And so she kind of wanted access to that sort of knowledge and used these things as a way to learn a little bit more about these sorts of technologies. At the same time, she said these activities made her feel in the present. She contrasted these with previous experiences of hers, building model volcanoes, or putting mint in soda, or dye in flower water, are the things that she conveyed to us, and that these activities with this technology felt like something different, and it felt like something in the present. So part of, in relation to seeing, feeling that she knew nothing and feeling that there's all this knowledge sort of embedded in these things around her, she said at first she wanted to do something crazy, but she decided to go back to small. And so she wanted to ask some small, and that question that she kind of felt was like basic. But she, so there were a few things that kind of went into her project. One was this feeling that she can't do something crazy, she has to do something basic. One was that she had felt that the plants were dying in the dark, and that's why the CO2 was rising. And she also had this interest in gardening, and she wanted to know why her plants were dying. So these sorts of things combined a bit to influence her decision to pursue a very basic question, which is just about plant death. Like when a plant dies, what is it doing? And so this question was something that was more personally relevant to her, and it was also, I think, speaks to an orientation to ask particular types of questions in science, to ask questions that are about what is death, not just what is the effect of temperature on CO2 production or something like that, but to ask a question like, what is death? What does that really mean for a plant to die? And so Hope was the student who I had shown that quote from at the beginning about this first spinach lab that she did, where she was talking about it as in this analogy to making chocolate cakes. And here, this is a very long quote, but she talks about herself creating data in this very different way. I'll pause for 1 second. Okay, and so what we see is that here when she's talking about creating this data, she's really talking about herself trying to prevent it from being interfered with by the material world, which is other students breathing on it, it was her breathing on it, and it was this sort of active process of like, this is the data that I need, and I'm trying to isolate it from the world so that I can get it, and I would try to keep myself away from the data. She also makes an analogy here and said to scientists' activity, that this is like something scientists are doing in their white rooms and for isolating their experiments from the world. And so here, we've been thinking about these sorts of resistances as kind of moments, as problems, like things that students encountered that they shifted practice in response to. And here we kind of see this different role of materiality or pushback from the material world as something that that positions you as this active agent in data production. And in this quote, she kind of hints at thinking of her data as a thing that's materially created, definitely, but also she's not really certain how much of her breath got into it. And so she kind of talks a little bit, speaks to this fact from artifact, sort of teasing apart that did my breath really get in it? I don't know. I'm sure it can. And some uncertainty that goes along with that. Her data, so she got a little pushback again, like experienced some problems, and that her data looked the same. She did these 2 conditions to investigate plant death, where she wrapped one in saran wrap and left it in the dark, and she, I think, wrapped one the other and left it in the light. And or I think maybe it was open and closed. But she created these 2 data sets that look visually very similar. And this is just a way, this is an artifact of how this technology that we use, how the software scales different graphs, that they looked the same. And so in this class, when she was trying to represent her data, she had showed me that these two things were the same, and I said, okay, do you want me to show you how to combine those to make them on the same? And so I kind of offered to show her this other tool that we have called CodeApp, which she could import her data to and then see these graphs together and really see how they compared. And so she got very engaged in this point and started asking me a bunch of questions that I didn't know how to answer about how do I color my points, how do I separate them out, how do I zoom in and only select a few of them. Another researcher was present in the classroom who is associated with that CodeApp project, and so this was a very lucky thing where she sat with her, and this student, Hope, had pulled up a chair to like make this researcher sit down and just like, no, show me how to cut down to my data. I want only 9 points. I want them 2 different colors. And so she was there for kind of a while where these things were really kind of resources for what she wanted to do in this activity, or to her data. And here, this particular problem that she ran into, that her data looked the same, the way that she responded to it when she got this new tool was to make her data look very different, like as different as she could. And she talked about, wanting to show others what she had done, and that she tried to do these things to manipulate her data to show others, to really emphasize these results that she had gotten. So, looking forward, thinking about these sorts of varieties of purposes that students bring to data production, to their different ways of engaging in it, different purposes for creating data, and still the role of materiality and resistances in having them really come to think about how data gets made. How do we support this in classrooms that are not like Mr. B's classrooms, that where teachers do have very tight learning goals, and we need to get to particular content goals, and we need particular data to help move us along there. And so how do we support both students' epistemic agency in producing data and doing it in ways that they find valuable, the ways that they want to do it, and still arrive at this target content knowledge? The other question that we're dealing with a lot right now is how do we build these sorts of resistances into these sensor-based laboratories? And what resources in particular do students and teachers need to make sense of them? So both students and teachers, we saw in these particular cases, they made sense of, when their data did weird things, they made sense of these things in a variety of ways. Sometimes if their data got flat, they said, okay, that's maybe my spinach froze, or maybe my spinach stopped doing anything, or maybe it was this, they didn't know about some of the behaviors of the sensors that affect these sorts of data. And so we're thinking about how do we build these moments into sensor-based labs that can be opportunities for students to learn about learn about sort of these technologies and how they are producing data. Okay, I'll show one more slide about how we're attempting to do that right now. So I had shown an earlier version of the spinach lab. This might be, hopefully it's not too small, but and this is not going to be enough to do it. This will require a lot of teacher framing and work done by teachers to support these. But what we're trying to do now is sort of rethink these activities as design tasks that students can engage in through both through design of ways to do things, ways to achieve things in practice, and also that where you can still engage conceptually equally just as much, and where there might be some room for trying things and redesigning things and doing things in this sort of iterative cycle. And so some of the things that we're building in are some knowledge about what is this data really, where does this data come from? How do you affect it? Can you boost your signals intentionally? Can you reduce the sensor noise somehow? So trying to support students in, well, if your data looks like this sort of squiggle on the right, here's what might be going wrong. And the last, or another thing that we're doing here is instead of sort of doing a data analysis stage after this, where we prescribe the ways that students are supposed to work with and then make sense of that data, we're asking them to tell us these data stories about what had happened and how did they make sense of it. And so this is a place to sort of open up not just a conceptual interpretation of what biological phenomena were going on that would explain your data, but also what sorts of did your sensor have a particular response time? Did it have a sampling rate? Did these things cause some features of the data that you're thinking about? And so by making these sorts of changes, we're hoping to for students to be able to produce data in their own ways, to engage in science in new ways, and also at the same time learn some more about how this data is really being produced. Okay, I should have a thinking question. Okay, any questions?
I have a question. So I saw that it was like a week 1 in the classroom. You did kind of previous lab, and then week 2 they designed their own project.
Yeah.
Can you just talk about how the teacher and you like framed that kind of design, because it's a very different way of thinking, like designing that, and like what you thought was effective for that, and then what things you have to like, all right, day 2 we kind of need to go back into that.
Yeah, so in between those two things, like in between their spinach lab and then that conceptual discussion, they did start again on the next Monday with some time on Friday to sort of brainstorm and think about what they wanted to do. But no, it wasn't particularly framed as a design task by the teacher to design something. He had talked to us about his goals of having students build their own setups, and it was a little bit with this, I think, with his maker orientation, that he was interested in sort of these hands-on building activities, and I wouldn't call it design necessarily for what he was encouraging students to do, but he told them to come up with questions and then go figure out how to answer them. Was a little bit more like how he framed that. Were you asking about the like?
Yeah, I was just wondering, was that just kind of like circulating in groups and came about random conversations? Were there specific protocols around that seemed effective?
Around supporting their coming up with, their brainstorming around independent projects?
Yeah. So
what he did was what he called a POIC, so it was predict, observe, inferences, and predictions of observations, inferences, and questions. And so this kind of went along with each of their activities, where at the end of one they kind of were left with some questions. In that classroom discussion that they had, he had them brainstorm a list of possible things that could affect those results that they saw, and told them, go investigate something. If you don't have any ideas, choose one of these things and vary it. And so his introduction to the task was a little bit more like that. Go find something to figure out and use these tools.
How many data sets were they encouraged to collect?
Yeah, there was we did not tell them how much data to collect, and the teacher didn't tell them how much data to collect. I mean, so we were kind of just observing this, but the teacher didn't really tell them how much data to collect. The way that he, they had decided, and some students we saw take, one data set this way and one data set this way, and then to compare them. The teacher, what he did was he would ask them questions. He said, how do you know that it wasn't this? How do you know it wasn't something else that would explain your data? And so it was kind of through his questioning that they might think like, oh, maybe I should have taken more data. And they thought of these things themselves too. Like I could have redone it. Taking more data was actually one that they're very aware of. It's not very clear how much data they need or why, like how much data would be enough to be sure that we know this. But a lot of them did mention, I should have done it more times. If I could do it again, I would do it more times. But the teacher's role was how we saw him interact with students was in asking them sort of questions about their interpretations and their findings. Yeah.
I was just wondering, have you worked with this teacher before, or like, what was the process of coming to work in this? Like, was there something particular about this classroom that enabled the students to kind of engage in this process, or?
Yeah, so I hadn't worked with him before. I only met him at this teacher workshop that we did where we were working with a bunch of teachers in the area. And so he just kind of, I'm not sure if he reached out to us actually, or to the PI on the project, or if she did to him. But he said, I've got some time in a few weeks and I would like to do this. And so we came with fairly little preparation actually, and provided these tools and then observed.
But yeah, I'd imagine with just like any teacher officer, there might be some prep time to kind of like figure out how to set that up in a classroom and develop a classroom culture like that.
Yeah, so I think a lot of this classroom culture of his was this classroom was in place. This was in March, and I think that this was a semester-long course that had started this was in April, and they had started in January. And so I think they were fairly familiar with it, though this did seem, to the students, it seemed kind of out of the blue that we were just doing volcanoes and now we're doing spinach, and they thought it was kind of strange. But the teacher in particular, he had a background in science. He had, I think, been an engineer for a while. He was was the maker teacher, so into and very knowledgeable about electronics and how these things worked. And so his degree of comfort was very high. So as he walked around and talked to students, he did sort of know a lot about how these things work and how you might sort of explain them to students. And this is something that we're trying to figure out when you have teachers who do not have, an experimental science background and they weren't engineers. How do we help them think about data, and particularly messy data or data where it's very variable? And so this is one of the things that we're currently working on is when you do these sorts of activities with students, when they're all creating different types of data, how do you support teachers in driving whole class inquiry forward with these various weird data sets that are kind of hard to explain? Individually they're hard to explain, let alone as a collection. Like how do we use this? Though we do think this is worth figuring out for the ways that students can ask and pursue questions in science class rather than kind of where we tell them how to do things, how much data to collect, and how.
So your presentation reminds me of a book called Dare Data.
Dare Data?
Have you ever heard of it?
No.
It's amazing, and
Yeah.
I think you would love it.
Okay.
It's about two scientists, two women, one in America and one in like London or something.
Yeah.
And they met at a conference, and then they made a pact that each week they would take turns sending each other postcards. But the postcards were handmade, and it would be about random data that they would collect throughout their day. So for example,
Yeah.
the amount of times I said today, right? And they would track that
Yeah.
with the time, the amount, but the key was, what made it special is that they turned it into art. So it's
Okay.
extremely beautiful, and it's really nice to look at, but it's actually reflecting like actual data about kind of nonsensical things, but still data.
Yeah.
Yeah.
No, this is interesting. So that particular, orientation toward data and art was something that came up in this classroom and also in discussion with Hope here. So we had a visiting researcher who had heard she was an artist. So she doodled a lot and she was into art. And she said, that there are people who make data into art.
Mm-hmm.
And then showed her a researcher who does this sort of data art, and the students sort of remarked on how beautiful this woman was who was making this data and art. And so we think that those sorts of moments like that, where you connect to students' interests
Right.
and their particular identities and ways of wanting to do things, that are moments to see, this is people are producing data. People are producing data with art. That these sorts of moments might be important ones.
Along those lines, you mentioned the student, Mala, who you said brought playfulness
Yeah.
into what she was doing. And it sounds like she brought it in herself. And I'm wondering whether there's anything that you see that you could do that could give other students permission to be playful
Yeah.
in a setting like this.
I know, and I mean, I think the question is, so some students want to be playful, and some students want to do design, some students want to do programming, and some students want to do science, and there's lots and lots of opportunities for students to do all of those things within science class, but we do have to figure out how to support them in doing those things in the context of, sensor-based science labs, where we do want them to make particular sorts of data and to get to particular conceptual goals at the same time. And so yeah, this is something that we're trying to figure out, like how do we change the things that students can do in science class, especially in these contexts that are typically very, very constrained, so that they can be playful, or they can make unique data and do things and approach that in their own way.
Any other questions? Thank you very much for the talk.